Hi again! This is the part 12 of our Godot 4 tutorial. Last time we added a boss enemy to the game level and mentioned that the player should have some more powerful weapons to fight it. Let's add explosive missiles to the ship's arsenal. Considering that the boss will possess a powerful shield, more powerful than it already has, it becomes crucial to provide the player with an opportunity to acquire additional firepower. To achieve this, let's introduce explosive missiles into the game. These powerful projectiles will grant the player the ability to inflict substantial damage, allowing them to effectively counteract the boss's formidable defenses. To streamline our process and minimize effort, let's begin with duplicating the scene missile tscn. So we'll press Ctrl D and create new rocket. Okay. It's important to note that the original scene is associated with the script enemy GD and has specific layer and mask configuration. So we cannot just utilize it directly in its current state. We must make the necessary modifications before proceeding. So let's close the missile and open rocket. And let's unlink the script enemy GD. And instead we will add the script bullet. Because it is a projectile, even if it's propelled by the jets, it's still something that would hit enemies, so this is how we can reuse what we already have there. Now we will set the collision layer to 3 and mask to 5. And the root node, which we'll rename to rocket, will be added to the group, to a new group. So it's no longer enemy, no longer metal, it should be missile. Yeah. We know that the script bullet GD uses a child node trail to process the line 2D trail behind the projectile. So if we want to use it for the missile, we need to copy it first. So let's open the bullet scene, select trail, Ctrl C, back to rocket, Ctrl V. Okay, let's save it. Now, of course, the rocket should be slower and more powerful than a bullet. So we will modify the exported parameters. Let's say hit points are 500. It will explode, so it should make a really big damage, and set speed to 50. Open the script enemy GD, and we will add a check for the group missile to the function on area entered. Let's copy this, or area entered missile. Most likely it's not necessary now because we are using layers and masks, so the condition is in group might be removed at all, but I think it doesn't make harm to have it there. Even though, what if in the future some enemies become immune to certain ammunition types, then we will be glad to have it here. Okay, and now we'll open the script main GD. There it goes, and we'll add a new function, fire missile. Let's add it here below fire bullet. So func fire missile. And again we have to check if the player's ship is still present. Player, because if the player is destroyed and we click the button that launches the missile, it will still try to do so. And now we will detect the missile weapon node. Missile weapon is player get main weapon. This is another function which is not implemented yet. We can have it here as a placeholder. So if missile weapon was found, let's start with the usual stuff, like we cannot fire missiles too quickly. We will need to have a cadence and a cooldown, and it seems that it would be great to add these variables first. Let's do it here. Var missile cadence is once per second. Var missile cooldown is 0 at the start, and of course we need to import a scene because we'll be firing the missile from this class. Where it is? So let's see. Yeah, rocket. So we will do this already stuff. Var. Yeah, I know, missile rocket, it's a bit confusing, but for some reason I got used to this word. Let's keep it as it is. Let's get back to the function being edited, and now if missile weapon exists, we will set the cooldown to the cadence value. Missile cadence, okay. And fire the missile. Var missile is missile scene instantiate, and init with the node where it should start its journey to the enemy. Again, add child. This time we don't need to refer to root node because we are inside the root node, the main script. I think in the future we might move this method to the game manager as well, but for now let's keep it here. And sound manager fire missile, because it should definitely have a different sound, like instead of pew pew pew. Fire missile, sorry, missile. Okay. Now how we want to fire it? We need another action in project settings, input map, and let's add action fire secondary weapon, and let's map it to the right mouse click, and it's mapped. And let's add detection of this secondary key to the process function. We already have this one for shooting the primary weapon, so this time we will change it to, or copy and paste and do shoot secondary. Okay, and not fire cooldown, but missile cooldown, and fire missile. Okay. And of course we need to decrease the value of the missile cooldown here, otherwise it would never change. Missile cooldown decreased by delta. Now we are already calling this and it doesn't exist yet, so just like we did before, let's add a new sound. So open the sound manager. It should be here in autoload, sound manager tscn, and we will create a new child node, audio stream player. Let's rename it to missile sound, and I already downloaded a pretty cool sound from freesound.org, so I will just move it here. And let's not forget about the unintentional loop. Import change to loop mode disabled and re-import. Now we can finally move it to the property stream here and control drag missile sound, and let's create a function fire missile missile sound play. Okay, we can fire missiles, which is great. However, due to their destructive nature, it's essential to ensure that the player doesn't have an unlimited supply of missiles at their disposal. To address this, we will introduce a new power-up that grants the player an additional missile. So they will have to destroy something first, then get this specific weapon. So we'll do it in Blender again. Let's open the project. This is the project we created before with the power-ups W and S. So we'll use the same way to create M. Shift A, text. Now press Tab for edit, change it to M. Let's click this A, object data properties, and we will assign the font, which should be here. Yeah. Now we need to make a 3D letter out of that, so we'll find the extrude property and drag it. Okay, and let's set the bevel to 0.03. Yeah, looks pretty fine. Let's get back to the object mode by pressing tab, right click the object, convert to mesh. Very well. Now, because the number of vertices is too high, let's click here and add modifier decimate. Let's drag it to the left and until we get below 1000, I think. Yeah, that should be fine. And let's not forget to apply the modifier. And of course, it's not oriented correctly, so we will activate the it's already activated, move gizmo. Let's drag it by these arrows to match the origin. That should be fine. And again, as you can see, this is the center point of the of the letter M, and it would cause bad rotations. Let's right click in the set origin to 3D cursor. Now it is correct. Let's save, Ctrl S, this scene and file, export GLTF. And let's find this folder, export. Good. Let's get back to Godot and find models. There it is. It should be here. Where the hell did I export? Yeah, sure. Sorry. Power GLB. Drag here. It should be there. Let's right click and create a new inherited scene. Let's take a look. Yeah, 3 letters. So we want to keep just the last one. Let's delete this node. We cannot yet. We must change it to area 3D first. Let's do it. And now delete one node, delete another one. Only M is there, which is correct. We will assign the model, the material, metallic, and add the collision shape, which would be a sphere. Right, and let's change the name to Power Up M, and let's save it to Scenes, Power Up M, TSCN, and assign the script, which would be Power Up GD load. Great. Once we have the power up, we need to spawn it. So let's do it in tutorial. and we will assign it to one of the missiles there. First, let's add it var power up m scene equals, and the scene is here. Okay, click and drag, control I mean, and we will make a parameter, optional parameter. If it's true, it means that this missile drops this power up, drops the M power up, so it can give player the missile weapon. Power up is by default false, so we don't get an error here as the parameter is omitted. Okay, and now this is correct, this will stay everything. What we need to add is the property power up, and it would be the power up M scene if the parameter power up is true, else null. Okay, now we need to add a new variable missiles to player, because we want to keep track how many missiles the player has at their disposal. So we will add it here, for instance. Missiles is 0 at the start, and there is this missing function get main weapon. We need to add it, func get main weapon if weapons for weapon, because it could happen that this function would be called before the weapons are activated and the array is filled. So this is just precaution. In weapons, if weapon name is main, yeah, just for the sake of simplicity, let's not add another weapon to fire missiles. We'll do it from the main central weapon as well. Return weapon, and if it's not found or something is not initialized, let's return just null. Good. Now we need, of course, to let the player know how many missiles they have there. So we will call on update HUD from the fire missile function. Where did we put it? Ah, of course, sorry, main GD, not here. Okay, so this is already implemented, and we need to add one more check. If player missiles is greater than 0, because if there is nothing in the stock, there is nothing to fire. If missile weapon, missile cooldown, var missile instantiates unit, a child. Of course, once we fire the missile, we need to decrease the number, the counter. Missiles decreased by 1, and let's call on update HUD, because we will add the missile counter through the heads-up display. Let's do it now. So let's open the heads-up display scene. Let's switch to the 2D view, and we simply just duplicate these two elements, Ctrl D, and name them, I would say, missile counter label, and of course there wouldn't be any progress bar. This must be changed to another label. Duplicate and missile counter, and let's change this text. There would be nothing here, or we can assign 0 as a default value and align it to center, and this text would be missiles Okay. And we need to activate a counter now. So let's switch to the script, and first we will drag this counter here as a new onReady variable and add set player values because it definitely belongs to the player. We will we don't need to tween anything because we just changed the number. Missile counter text is string made of the number defined by player missiles. Okay. Okay, there's a couple of things I did slightly wrong before. So first, I by accident named the action fire secondary instead of shoot secondary. So I renamed it here. And of course, we can pick the power up that there is no action mapped to this event. So we need to do it in the player GD script. There it is in process power up. We need to first define a new variable in power-ups. Let me show the script, and the new one would be export var add missile is false. Okay, and for power-up M, we'll set it to true. This is one thing, and the other one is, let's go back to the player GD and the function process of power up. And now if power up, add missile is set, let's increase number of missiles by 1. And we can finally test it in the game. Just remember, we need to get a power-up first, so we will have to shoot both missiles, only one of them would contain that. After we pick it up, the missiles counter at the top left should change to 1, and then we'll be able to fire the missile by right-click of the mouse. Let's do it. This, pick it up, you can see there is one here, and I'll fire it, and the whole enemy's shield was depleted. Not easily because we don't have the other power up, so if we collide with the enemy, we are finished. Anyway, the missile definitely works. Now, let me say a few words about further optimizations. Until now, we've been adding materials one by one, so we didn't face any issues. However, if somebody downloads our game and starts it for the first time, they would most likely face interruptions such as stutters and FPS drops when playing a level. And at times, the game may have appeared frozen momentarily. The main culprit behind this issue is typically the unexpected blocking of the main thread due to GPU operations associated with shaders. In fact, we don't use too many real shaders in our game. However, the GPU treats all types of materials as shaders and needs to compile them for efficient processing. The problem is that shaders are not compiled until the object, or specifically the material, is rendered for the first time. This is why we encounter frustrating spikes every time a new material is added. Unfortunately, it seems that Godot doesn't provide a straightforward method to force shader compilation, or at least I'm not aware of that. Maybe it will be possible in future versions. But until then, we can employ a simple workaround by displaying all materials on small instances of a quad mesh, just a very small square somewhere, during the level loading phase. Let's do it. We will add a new function to our autoload script utils, and let's call this function get all materials from scenes. And scenes, which is an array would be the parameter. Now we will return a dictionary of names and materials, so we will just define it here as an empty dictionary, and after that it will be returned materials. Now let's implement something. So we'll iterate through all scenes, and from the scene we want to get all materials. In new function, get all materials, which is not there yet. Scene. Yeah, we need to instantiate the scene, otherwise it wouldn't work. And once we have this array of materials, we would add them to the missing colon. We would add it to the dictionary. Materials, and let's make a string out of the particular material reference ID and get the real ID from that. These are standard Godot functions, and this is the key, and the value would be the material itself. Okay, there's one extra line. And now to implement the function get all materials from the selected scene. So func get all materials. I'll call it source node. All right. And this time we will return an array. So materials would be an empty array, and return it at the end of the function. So yeah, there is a typo, should be scenes, and the error will be gone. Good. Now let's do this. So iterate for child in get all children. This is our custom method we created here to get all materials recursively. Source node. And once we have it, we need to test if the node is mesh instance 3D. Because this is where the materials are assigned to. So if it is, let's call it mesh, and let's give it the type mesh instance 3D, because it will help us with the auto-completion of pretty long methods we will use. Is child as mesh instance 3D. This is just retyping the generic node to this concrete instance, so the editor knows what kind of method it should offer in the auto-completion. Now for E in mesh get surface override material count, because we don't plan that, but in theory we could have multiple materials on the same mesh, and we need to precompile all of them. Var material is mesh get active material. Yeah, we need only active materials, so with index I, if material is not null, because this can sometimes happen, and is instance valid. There are various situations that can result in an error, so this is just a result of my previous experiments with this method and making sure that it will always work no matter what kind of models and scenes we have in the particular scene. In this case, we will add the material to the array we want to return. Okay, this is just one case because we covered only I would say static non-shader materials, materials from our scenes. But sometimes we, for example, have particles or GPU particles and CPU particles, and we assign some material there as well. So let's cover that. If child is GPU particle 3D, always make sure you don't use 2D instead of 3D. It's very easy to make this mistake. Var particle of type GPU particles 3D is child as GPU particles 3D. Good. And the material is taken by this method. Var material is a particle draw pass 1. If you remember, we used only one draw pass in GPU particles to define the fire, the jet fire, and we definitely don't plan to create more complicated particles. And surface get material, this is the function, I think, yeah, the first index, zeros in fact. And again, if material is not null and is instance valid, it is just a good practice to call this function, which is something, yeah, what we, no, we didn't, is valid node. Use this function if we want to do some operations with a selected node, because in many cases, if it's not valid, Godot will throw an error and just end our game, which is not what we want. And material, yeah, sure, we'll add it to these materials. We could copy and paste that, in fact. All right, and now let's do the same thing for CPU particles 3D, which we use for sparks. Okay, and this should be faster. We just do some copying and pasting. And this time there is probably something else because it doesn't use multiple passes if it's CPU particles 3D. So instead it would be just mesh sir, I wonder why it doesn't suggest something, maybe because of this nope, surface get material. Okay, it should be correct. And again, if instance valid, we'll add the material to this. Okay, the function is ready, now we need to use it. So, because we want to call this force compilation on the level start, or more precisely when a new level is being loaded, we will add it to level manager. Let's open a level manager and add a new function, compile shaders. Node, we need a list of scenes, of course, and the root node to add these small squares into. So var materials is, and this new function get all materials from scenes. Okay, and for let's say key in materials, let's iterate, we will create this quad mesh programmatically. Var new mesh of the type mesh instance 3D. This is optional, it's not necessary to do that. You have probably noticed that we don't use this kind of strong typing anywhere else, but it's better if you want Godot to give you more sophisticated code completion. Mesh instance 3D new, and now new mesh. We will create a new group for this. because we want to get rid of all these instances once the materials are compiled, shaders are compiled. Oh yeah, add to group. Let's call it mesh. No, new mesh. Set surface override material. Basically, we are doing exactly the same what we've been doing in the editor by dragging materials to this property, surface material override, but this time we're doing in the script, so at least we can see the difference. Materials, now key, okay, and we want to put it to some position. Yes, and let's display this square at the bottom left corner. This is where it won't cover anything important. Okay, manager, boundary left, plus, okay, manager, boundary margin, and half of that. Y would be again 0. Int game manager now what's the problem here? Yeah, of course, problem is that I should have done it as a vector. Okay, now it should work again. Game manager, boundary bottom minus game manager boundary margin, which means this is not correct. Boundary margin and half divided by 2. Okay. And we need to add this node to the root node. But in this case, we will call the function asynchronously. So it's absolutely necessary to use the call deferred trick. Call deferred to make it synchronized. And the function is at child, as we know. And the object to apply it to is new mesh. Okay. In fact, it didn't throw an error before Godot 4.1. Now it does, so it is definitely the safer way to do it. And let's change the function init in tutorial, because this is our sample of a level definition, and we will later make it more, I would say, more common to include the code that would be shared across all levels. At this moment, we will add a new parameter, optional, more scenes. Okay. And some scenes are missing here, so we need to add them too. Let me see where it is. Here, I think it's the power up S. Okay, I just saved some time and added the missing scenes here, and also created an array scenes out of all of them. Now we need to use them in the shader compiling function. So we will just make sure that the scenes array contains everything, including the optional array, because sometimes we can send something from the main script, like the materials for the player's ship or anything else, so it would be definitely great to have it here as well. It won't cause any problem, because once the material is compiled, to display it is very fast. It won't cause any further lag spikes. And finally, level manager, compile shaders with our scenes. Great. But what's this? Of course, node. We need to pass the node. That's better. But of course, we'll still have a problem of blocking the main thread. Even if we do this and call it just like we do it now, the main thread would be blocked by this compilation, so we won't achieve anything. To resolve that, we will unblock it and we will call the function load level in a new thread. Let's switch to the main scene, and before we start adding the code, it would be nice to display some kind of loading please wait label to be there until the level is fully loaded. So we will switch to 2D and create a new child node of the type label, and let's call it loading label, and we want to display it at the center, so it would be where it is, center, there it goes. The text would be loading please wait, and again we want to use some better font. It's here in theme overrides, fonts. We'll find our fonts, there it is. Okay, and make it bigger. Let's try 24. Yeah, that should be fine. Maybe 30. Okay, this is correct. So let's switch to the script, and we will first add the loading box here because we need to refer to that. So that would be, loading label. Okay. And now we need additional variables. Level loading, which is false. This is necessary for the asynchronous call, and of course thread, which will be used to create the separate thread to load the level. Now in the function process we have this level loaded, which is correct. This is just how the game is being played, no changes here, but we need another branch, elif not level loading. Let's create a thread. Is thread new. Okay, and we will start it calling the new function. Again, we use the callable. It would be in this script, and the name of the function would be load level. And we want to call it with a parameter this time. So the way to do that in Godot, in GD script, is to, not here, here, is to bind the parameter. And we know that the name of our level is tutorial. So this is the value for our parameter. Okay. So let's create it. Func load level, level name, and now there is something I want to start with, and something is thread. Set thread safety checks enabled and set it to false. What is this? In Godot 4.1, I think that some kind of update that enforces stricter guidelines to ensure the safety of the application flow by allowing only certain operations to be executed from the main thread was introduced. If we don't do this, we will see hundreds of error messages in the error console. Actually, it probably won't affect the game itself, but it's always better to reduce the number of errors, ideally to 0. So this is why I edited here. And now the logic itself. In this case, level loading should be set to true as we started loading process. the current level will be from level manager. Level manager, there it is. Load level, level name. Now we need to init it, just like we did before. And we should add the player's ship there. So we need to add a player scene. Let's find it. Here it is. We'll put it here on ready var player scene and drag with control key. Okay, this is we need that to precompile the materials on the player's ship as well. So where were we? Here. We'll put the optional array with only one member player scene. And this method, actually the shader compilation is performed. So once it's done, there is nothing else to do. In this case, we can set level loaded to true, equals true, and of course level loading to false. Then, and one more thing, we need to finish this thread and we need to finish it safely. So otherwise there could be some leaks and the application will become unstable. And there again we'll use our favorite call deferred. In this case the method is wait for finish. Okay, and the loading label can be made invisible. Is false. Okay. Yeah, I think there is one more thing which was probably necessary in previous versions of Godot, but it doesn't hurt to have it here as well. And another proper way to exit threads is to call it here in exit tree, which is internal function that is always called when this particular scene, particular node is destroyed. So if thread we created is still alive, just anything can happen. So this is another failsafe, thread wait for finish. This time we can call it synchronously without the call deferred. And of course we don't need this part any longer, so we can get rid of it. Let's try the game now. Yeah, you've probably noticed that the loading text was there for a very short time because all our shaders and materials are already compiled. But as I said, if somebody else plays our games for the first time, this would definitely help them to get a better gaming experience. Next time, we will make plenty of improvements regarding the game workflow. We will introduce a simple menu screen, we'll learn how to pause the game, we'll work with the game settings and many other things. See you in the next video.